Okay, students, this is problem 3.9. A spring mass system with mass of 10 kg and stiffness 5,000 Newton per meter is subjected to a harmonic force of amplitude 250 Newton and frequency of omega. If the maximum amplitude of the mass is observed to be 100 milliliter, find the value of omega. So basically question wants you to find omega, all right, which is the force frequency. So you can also find this through the formula that we use in problem 3.1, which is from the lecture slide 6 week 4. All right, you can use this formula to find your omega. But first, the question already gave you the x, the amplitude. You just need to find your static deflection, all right, and also your omega n. We have to find both of that first, only then we can find omega. So use that formula. Okay, the first step is to find your omega n. So omega n equals to set k over m, where your k is 5,000, your mass is 10. So once you calculate, you get your omega n to be 22.3607 radian per second. The second step will be to find your static deflection. So your static deflection equals to harmonic force, all right, harmonic force divided by the stiffness, and your harmonic force is 250 Newton, okay, divided by the stiffness, also still 5,000. So once you calculate this, your static deflection, you get it 0.05 meter. Okay, next you can find the third step is to find the omega using the formula from your lecture slide. So the formula is x amplitude over static deflection equals to 1 minus 1 over 1 minus omega over omega n square. Alright, you want to find omega now. So I'm just gonna rearrange the equation first, so that we, once rearranged, we can just substitute all the values to get omega. Okay, so we want to find your omega, the force frequency. So I don't want this one here, so I'm just gonna put everything upside down now. Now I'm going to bring 1 to the left side, so you'll get 1 minus del st over x. Okay, now I'm going to bring the square to the left side, so it becomes square root. Omega over omega n. And lastly, omega equals to, I'm going to bring omega n to the left side, so I'll get everything in terms of omega. So this is the last one. Okay, so now I already have this, so we can already substitute the values. So substitute all the values now. Your omega n is 22.3607. Square root 1 minus your static deflection is 0.05. And your amplitude now, okay, maximum amplitude is 100 mm. So basically your x is 0.1 meter. Okay, everything needs to be in SI unit. So your x is 0.1 meter. So calculate this, you get your omega to be 15.811 4 radian per second. Okay, so this is the answer for this is a solution for problem 3.9.